In this quick demo, I would like to show you how we can approach the problem of matching physical properties and colors between our reference object or material image and our own material we created. So for reflectivity, it's really good to try to have as many reference objects as possible from various distances, close-ups, further away, ideally with lots of reflection, non-reflection areas. For example, here we can clearly see that this is a super plasticky, super glossy surface. And here we see more top values actually being reflective. And then here actually everything is kind of reflective. So how do we actually do something then like here? Now this is now where based on the images, we can manipulate our overall reflectivity. We can also manipulate our overall roughness. Is it very rough or is it more soft? We can even add a clear coat over it. So think about the clear coat as another piece of a polyurethane layer that we put over it. And you see the base material I made non-reflective, but then have just another reflection on top. That simulates kind of like the effect of having this plastic surface on the steel and then later I put another polyurethane layer over it with a high glossy filter. We can even add a little bit of um, roughness to the clear coat too, and this clear coat does ignore the bump mapping. So pretty cool. Okay, so let's put all this back. We just work with this for the moment. And here in this, we can see how everything is kind of reflective, but maybe we would like only to have reflection on top of these corners. The inner parts maybe are less reflective, just to show you how we can achieve something like this. So we have here our bump mapping. We have this, and this, for example, I will put into the specular channel. Wait a moment, and then here when we zoom in, here let's hide actually this color so it's easier to see. There you see the reflection is only on top. The valleys are actually removed. You see it's pretty cool. If we want to have more reflectivity, not necessarily where the color is, it might be a good choice in that moment then to simply do something like this. So I added another color ramp. And then with this color ramp, I can play with these values a little bit more. Or what happens when we put this one directly in. Okay, so this is actually, oh, there, not tint. Okay, not so good. What about when we use the mix RGB? And then we set this to black, and then this we set to white. Okay, so this is basically, it takes this input and then generates a map for it. And when I set this to white, you see everything is actually reflective, and now only certain parts are reflective. So I'm kind of like tinting the oval image of it. So now I get more reflection into the valley or less. So now I can even do something like this. And then we put this back. And then there you can see now how this is on top. And if we want even here, maybe have a clear coat put on top. Think about it, maybe the way what we're doing is the plastic is actually somewhat reflective, but less. And what is white here, that's actually where we sanded the plastic off, so we have a higher reflection. But that's just kind of like what we set up with this material, and then we put another clear coat on top if we want to. Okay, very good. So this kind of like covers a little bit more of working with specularity and roughness and even adjusting what is reflective via a node. So either the color ramp or color mixer. The biggest difference between color ramp and color mixer, right now to explain this one more time. Here I have A to B. I have also A to B, but I can position them on a scale so I can clamp the values more. That's the main difference. Otherwise, the output is pretty much the same. And color matching, that's the last topic. So let's say here we would like this beautiful green to get over. How can we do this? Okay. Let's take a look at this and we make a screenshot. There we are. So the screenshot we save. This is not necessarily considered a very color correct process, but it works to a certain degree. Let's load this image into an image viewer and then we can zoom in. Obviously the shadow areas we don't want to work with, but hopefully somewhere here we can try to find something that is not too illuminated, not in the shadow, but somewhere maybe in between. So this blue I would like to look like this. And it's very easy to do. Click on the color, click on the eyedropper, and then we just sample the color. And there we are. So you see quite easy, maybe the darker tone. And then from an image, we can sample colors over. Now in manufacturing, we have actually color systems in place. One, for example, is Pantone. We have Pantone for print, but also for product colors. They come with their own RGB values. So then when we do a rendering, we punch in actually the RGB values or the hex based on what they have. And then the color mixer generates the color that's very close to the Pantone color, if in case it can be reproduced. Not everything we see here can be reproduced because these are object colors and they're particularly generated. And in digital rendering or computer graphics, here we work with RGB, so with light colors, and we need to translate them because these beautiful solid red, solid blue, these are not necessarily colors we can actually manufacture. Which is also why when you handpick colors, try to be careful. Don't go to these full extremes. Go to somewhere more in this area or a little bit closer to the center. These colors are more natural than like a full saturated color like there. Or when we go to the HVS, we have the hue, then we have the saturation, and the value is the brightness. Okay, very good. This is then everything about also how to very quickly, when you have a color reference or a product branding color, how we could get this color into Blender.